Now let's talk about something really cool. Polarized light and 3D viewing. A pair of photographs or movie frames taken a short distance apart, about average eye spacing, can be seen in 3D when the left eye sees only the left view and the right eye sees only the right view. Vision in 3 dimensions depends on both eyes giving impressions simultaneously from slightly different angles. The combination of views in the eye-brain system gives depth. A pair of photographs taken a short distance apart is seen in 3D when the left eye sees only the left view and the right eye sees only the right view. So we get this vision, this seeing the same image from 2 different angles because we have this bridge in our nose, the spacing between the eyes. That space right there allows us to see the light coming into our eyes, going to our brains for processing from 2 different angles. And as long as you are able to clearly see from both eyes, you should be able to have this depth perception, this 3D effect, where you see that things, you know that this hand is in front of me, or maybe it doesn't look like it's in front of me because you're looking on a flat screen. But if you hold your hand up in front of your own face like this, you will know for sure that that hand is in front of whatever's behind it, just because you have this depth perception. So the 3D movies work the same way, where they have the same image. Let's say we have one image here, and we have another image here. It's the same exact image, but they slightly keep them separated. So rather than have them stack on top of each other, trying to get this angle right so you can see it, rather than have them stack on top of each other, they're slightly off. And if you take your 3D glasses off in the movie theater, you can see the 2 different images. Slideshows or movies can project a pair of views through polarization filters onto a screen with their polarization axes at right angles to each other. The overlapping pictures look blurry to the naked eye. To see in 3D, the viewer wears polarizing eyeglasses with the lens axis also at right angles. Each eye will see a separate picture, and the brain is going to put it together to give it that depth perception we talked about. A 3D slideshow or movie uses polarizing filters. The left eye sees only polarized light from the left projector. The right eye sees only polarized light from the right projector. So you have the projector on the left having an image going all the way over here to right here, which your left eye is able to see, and then you have a projector on the right, which is polarized vertically. So you have one polarized vertically, one polarized horizontally. The glasses, to see the polarized horizontally light, you have to have horizontally polarized glasses. So you'll have one on the left, and then you'll have a vertical on the right. A lot of times you'll see 3D glasses having different colors, magenta and cyan, the blue and the red looking glasses. That tells you the direction of the polarization. Depth is also seen in computer-generated stereograms. In computer-generated stereograms, the slightly different patterns are hidden from a casual view. You know these as the Magic Eye book series. We're going to take a look at that in just a second. So which pair of glasses is best suited for automobile drivers? Got A, which has 2 vertically polarized lenses. B has 2 horizontally polarized lenses. And C has 1 vertical and 1 horizontal. Pair A is best suited because the vertical axis blocks horizontally polarized light that composes much of the glare from horizontal surfaces. Pair C is best suited for 3D movie. Look into my eyes. Keep staring at my eyes. You can also pause the video and just stare at the center. Is it growing? The blackness? No, it's not growing. Let's do another one. Look at me over here. Keep staring in my direction. You'll notice that some of the picture is moving until you look at me over here. Now, some other parts of the picture may be moving until you look at me down here. Here is the magic eye I hinted at earlier. To see this image, you need to make it full screen, pause the video, and gaze near the center. Just let your eyes completely relax. Don't stare specifically at a spot. You're just taking in all of the light. As you do this, you may start to see an image pop through. I'm going to give you the solution so you can rewind it to see if you can see it if you want. Solution coming now. Did you see it? Here's a fun trick of the brain. Read that sentence. What did it say? Read it again. You probably messed it up. No, seriously, read it again. Read it out loud. Point to each word as you read it. So how can you see photographs or movies in 3D? You should be able to comfortably answer this by now.